Tonight, we want to celebrate a simple activity we just don't do enough. Going outside, looking up and marvelling at the night sky. We're not just talking about observing the stars, we're going to explore some of the more surprising ways that the night sky can captivate us.
We're at the Royal Observatory, Greenwich, the spiritual home of British astronomy, to find out how we can all enjoy the majesty of the night sky. Welcome to the Sky at Night.
Astronomy is, of course, the very heart of the sky at night. But it's easy to overlook the sheer variety of ways in which the night sky can inspire and even provoke us.
So tonight, with Christmas only weeks away, in a spirit of celebration, we're going to enjoy the many ways the night sky can bring us pleasure. Chris learns about the ancient art of navigation using just the sky.
This is one of the most ridiculous sentences anyone has ever said on an astronomy programme. Pete and Maggie take on an epic challenge, trying to persuade a group of teenagers to fall in love with stargazing.
And Chris discovers how astronomy can reveal a spectacular world of colour hidden in the sky above. But first, I'm going to Norway in search of one of the greatest spectacles the night sky has to offer. The Aurora Borealis. Perhaps the most surprising thing about the aurora is that there is much that, even now, we don't understand. New discoveries are still being made, and it's not just the scientists who are making them. You can sometimes see the aurora from the UK. But to increase my chances of seeing them, and to learn more about them, I've come here to Tromsø in Norway. Now you might not believe this, but the sun has just set and it's getting dark, but it's only 2 o'clock in the afternoon and it really is quite cold. Tromsø nestles between the fields of northern Norway. It's been a working port for many years, but it's also a centre for aurora research because it has one of the most reliable records for aurora displays anywhere on Earth. Thank you. I just can't wait to see them with my own eyes. Kjetil, what's the probability of us seeing the Northern Lights tonight?
I think it looks good tonight. The weather is clear and that's what we need. Tromsø is probably one of the best places on Earth to see the Northern Lights. Not just because I live here, but we're placed straight underneath the Aurora Oval, the imaginary oval of particles surrounding the North Pole.
So we've been driving around for about half an hour now, and I'm beginning to see what might be the Northern Lights. It's quite hard to describe, but there's that sort of a wispy light in the sky, and I'm really hoping that's it, so we can hopefully pull over and check it out. Wow. It really is them. A band of colour across the sky. This is amazing. Anything that usually gets between me and the stars is a bad thing, but at the moment this is just so glorious. It's so much better than I thought. So much more dynamic, so much more colour. I'm just loving it, loving every second. I can actually see a sheet travelling across the sky. But what exactly are they? Well, it turns out that they're not as well understood as you might imagine. It's been thought that they were caused by electrons from the solar wind, twisting along the Earth's magnetic field, ionising gas in the atmosphere, which then shimmers and glows. But there are some fairly obvious problems with this theory. Aurora expert Melanie Windridge explains.
Firstly, we know that if charged particles were coming in directly from the solar wind and hitting into our atmosphere, they'd be hitting us on the day side of the planet. And we don't see aurora there. It's too light.
Yes.
We see aurora at night.
Yes.
So somehow the particles are getting round to the back of the planet. Another thing is that we know that if the particles were coming in directly from the sun, then they wouldn't have enough energy to cause the bright, vibrant displays that we see on the night side.
New research has begun to suggest an answer. The electrons coming from the solar wind are receiving an unexpected boost in energy from a complex interaction with the Earth's magnetic field.
The Earth's magnetosphere is the Earth's magnetic field, but then modified by the solar wind. So the wind comes past and it's deflected around it like a stone in a river or something like
Yeah, I
that.
have seen that. So you've got sort of the Earth's magnetic field, and it would be sort of around the Earth, but it has a sort of, it's elongated.
Yeah, it's stretched
away from
out.
the solar wind. Yes.
Exactly, like a windsock.
Yes.
As the wind is deflected past the Earth. And so you have this long tail, this long windsock-like tail behind the Earth. And in that region, you get a lot of magnetic field built up and pushing down behind the Earth. And eventually these magnetic field lines get so close, but magnetic field lines can't cross, and so that's when they get pushed close, and then bang, they snap. And when they snap, they catapult back towards the Earth, and they catapult particles, electrons, down the field lines into the Earth's atmosphere at the poles. And that's what's causing the aurora. It's that acceleration of particles. It's giving them a lot of energy, and that means that they can interact with our atmosphere and cause the bright lights that we see in the night side.
Just looking up here tonight, there's so many different phenomena happening.
We don't fully understand the causes of the movements or the dynamism. We're beginning to understand pieces of it now because we have better technologies available to us now. We have satellites up in space, and that's really useful because we can fly through space and we can measure things like particle densities or particle speeds or what the conditions are like out there. And the aurora acts as a kind of window onto the processes that are happening in space. Or if you like, the atmosphere is the screen on which the aurora plays out, but it's playing out because of things that are happening out in space.
But I suppose we have many more cameras than we used to, because we have the sort of the professionals, but I also guess we have amateurs doing some amazing stuff and taking some amazing images, which we can relate to what's happening up there.
Exactly, and that's a really good point because we're now able to get, well, many more pictures than we ever used to be able to get. Just recently, in the last year or so, there's been a new feature identified in the aurora, which is quite amusingly called Steve, because they didn't really know what to call it, perhaps.
Dave was taken.
Exactly, so Steve. And Steve is like a ribbon aurora. It's like a pinky white ribbon. It's quite different to the normal green arcs or bands that you see across the sky. And it happens at a slightly different orientation, so a little bit more towards the equator than the main auroral band. And I think people have actually been seeing it for a while, but it's fairly rare, and so it wasn't seen very often. But now that more and more people are taking photographs, it was popping up in these photographs more and more.
So what do they think's causing it?
They know now that it's happening about 300 kilometres up in the atmosphere. It's about 25 kilometres wide, but they don't know what's causing it.
I can see some more developing just behind us, actually.
Oh yes, it's looking lovely out there. I want to watch it.
So it's still a mystery, but a mystery that we're solving slowly but surely with the help of citizen scientists. So it is a fantastic thing to observe. Thank you so much for explaining.
You're welcome.
Although the aurora is full of colour, it's easy to assume that the rest of the night is a monochrome world, one with an inky black sky and a sprinkle of white stars. But there's plenty of colour up there to enjoy, if only you know where to look. To explore this hidden universe, I met up with astronomer Jen Gupta at the Royal Observatory, Greenwich. So Jen, we're here to talk about colour in the night sky, and that's odd because people think of the nighttime world as black and white.
Yeah, so if we look up at the stars, and we can see some stars here tonight, you think of stars being kind of these white pinpricks of light. You don't think of much colour being out there. But actually every star in the night sky has its own colour, and the classic example I think at this time of year are some of the stars in the constellation of Orion. So Orion is just rising here in the east at the moment. The classic stars you want to look for are Betelgeuse, his top left as we look at shoulder or armpit, The other one that you want to look out for is Rigel, which is his bottom right foot as we look at it. And if you look closely at those stars, you'll see that Betelgeuse looks a kind of orangey reddish colour, whereas Rigel, it looks white to us, but it's actually more kind of whitey blue.
So why is that? Why are those two stars different colours?
And this is all to do with their temperatures, and it's a little bit confusing to start off with because it's actually because Betelgeuse is cooler than Rigel. Then it's the physics that's driving the stars. So we've got an example here. This could be my star. So we're going to start lighting up this light bulb, and what's happening is we're going to make the wire inside glow, and you can see here it's kind of glowing an orangey colour.
Right.
As we increase the power through it and we make it heat up even further, you can see the colour starting to change through to a kind of yellow, and if we kept going, I don't want to do that, it will get a little bit too hot, but it will end up glowing very white basically.
And so just by looking at the colour of the light bulb, I can work out the temperature of the filament.
Yeah, exactly.
And the same is true with the stars, but for different reasons.
Yes, so there's a different process that's going on. What's happening in stars is actually a process called nuclear fusion. It's mostly hydrogen, the most abundant element in the universe. Hydrogen atoms smashing together to form a helium atom. And that's the process that's powering the sun, that's the process that's powering all these stars.
And this is true for most stars, but because they're different temperatures, we get these different colours.
Exactly. And so when we look at Betelgeuse, we're looking at a star where the surface temperature is around about 3,500 degrees for Betelgeuse compared to about 11,000 degrees for Rigel. So you've got a big difference in temperature.
But there aren't many green stars in the sky. That seems weird.
No, but there are other things in the night sky. If you're desperate to see something that's green in the night sky, that we do have other options. And in fact, there's one in the Orion constellation again. So if you find Orion's sword hanging down from his belt, there's the Orion Nebula inside there, that kind of fuzzy looking star. But if you zoom in on that with a telescope, you actually see that it's glowing with colours. What's happening in the Orion Nebula is that the gas is being lit up by some young stars that are forming in this cloud of gas, and that's doing what we call an emission spectrum.
So the gas is getting excited.
Yeah, we're giving energy to the gas, we're giving it lots of energy, and we're making it glow. And we've actually got these 3 lamps here which can do exactly the same thing. So if I flip this one on, you see that it starts to glow. The exact same thing is happening. We're putting energy into the gas inside that tube, and we're making it glow, in this case, a kind of pinky purple colour. And so this gas actually inside there is hydrogen. If I switch this one on, this will maybe be more familiar to people. This is neon. So your neon signs working the exact same way. And then finally here we've got helium.
And the different colours are just because there's different gases.
Exactly, so that's what you'll immediately notice. They're all glowing in different colours because of the different atoms that are inside this gas. And so we can work out what is inside our nebulae by looking at the colours coming from them.
And so when I see Orion as green, what does that tell me?
That's actually oxygen in the nebula, but what you'll notice if you see photos of the Orion Nebula, maybe taken with the Hubble Space Telescope, you'll notice they're actually much more like this colour. They're more kind of pinky purpley, and that's because there's a lot of hydrogen in the nebula as well.
But it is amazing that just with the stars and even with the nebulae, we can tell so much from a very simple observation just by asking what colour something is.
Exactly, and this was kind of a revolution the end of the 19th century, early 20th century, this technique of spectroscopy, being able to identify what's going on in these gases, in these elements, just from their colours. And it's really the birth of modern astrophysics.
All this just from looking at colour. Jen, thank you very much. Coming up, we'll be exploring the ancient art of navigating by the sky. But first, most regular viewers already know that the night sky is full of wonders. But there are plenty of people out there who have yet to be initiated. So we set Maggie and Pete a challenge. Could they convince a group of young people who've never had the chance to appreciate the beauty of the night sky to take a look at astronomy?
We're here at the Ashton Mersey Sixth Form School in Manchester, but we're on a mission to inspire the next generation of astronomers with the wonders of the night sky.
The weather's a bit challenging. We've got lots of clouds scudding through, but we're going to give it our best shot.
So what are your experiences with the night sky? Have you done much stargazing in the past? No. Do you notice the stars and the moon and stuff?
Yeah.
Okay, that's good.
Have any of you looked through a telescope before?
Yeah, from Argos. Didn't see much.
Okay.
Oh, right, yes. Do you know how many planets, for instance, are in the solar system?
Is it 12?
That's slightly high. Does anyone else have a guess? Okay, that's a bit low now.
9.
You're getting really close to 8.
8, yes. Well, see, when Pluto was demoted. Yeah. So it used to be 9, but no, Pluto was demoted.
Okay, so we've got the moon, but I've set the telescope up so that that's pointing at it. There's a bit of cloud down there, but if you want to have a look through the eyepiece, go on, have a go. Is that, the eyepiece is there, so you're looking in the side. Can you see it? It might be tricky.
I might see bits of it, but... Oh yeah, I can see it.
You see it? Can you see any craters on it?
What's a crater?
It's sort of like where something's hit it and it's left some indentations in it. Like cheese.
Yeah.
Those craters are caused by lumps of rock in space hitting the moon, and it sort of leaves an impact crater.
Those craters you're looking at there are about 100 miles across.
Oh my gosh. You wouldn't think it has like all that in it, would you?
That's incredible. The moon is amazing when you really get in close to it. Right, if you have a look through there at the 2 stars, do you want to have a go? Look at them carefully, and can you see the difference in colour between them?
It looks like an aeroplane.
One is yellowy in colour.
The other one's tiny. One's yellow and one's blue, is that right?
That's right, yeah. This is a star, it's called Albario, and they are thought to be gravitationally linked, but they look beautiful because one of them is yellow and the other one is a bluer star. Oh look, there's some stars up there. Oh, we should be able to see the W of Cassiopeia. It's right up there above us. Now, if you've got the W of Cassiopeia, you might get the Pleiades, you know, coming in. The Pleiades would be nice.
So the Pleiades, or the Seven Sisters, is something that we call a sort of an open cluster. And these are sort of like stellar nurseries, so it's where stars are born. Well, how do you feel about that?
That's the
Best I've seen.
Well, when we started off, you hadn't looked through a telescope or seen anything in the night sky, but now you have seen a few things. What do you think now?
Fascinating.
It's amazing that there's so much out there that we don't know about.
What's the best thing you've seen tonight?
Probably the moon.
Yeah.
Looking close at it. I just want to find out more now, though.
That's always good to hear, yeah.
Right, okay.
I never knew that stars are different colours either.
Right.
Yeah, that was interesting.
We've done a good job here tonight.
Yeah, I think our work here is done.
Yeah, definitely.
Go forth and buy telescopes. No.
If all our talk about the beauty of the night sky has whet your appetite, then you might want to get some astronomy equipment of your own. So what do you need to dip your toe in the water? Pete Lawrence has the answers.
Now, it's great to be outside looking up at the night sky with just your eyes, but you'll get to a point where you want to go a bit closer to them. You want to see more detail and have a bit more magnification. And the best way to start doing that is to use something like a pair of binoculars. And binoculars are defined by 2 numbers. For example, these are 7 by 50s. Now, the first number indicates the magnification of the binoculars. The second number indicates the diameter of the front lens in millimeters. And that's really important because the larger that value, the more light gathering power a pair of binoculars have got. Now, binoculars are wonderful instruments to give you an overview of the night sky. They're wide field instruments, so big clusters will look beautiful through them. But there are occasions where you want to get a bit more magnification and a bit more light grasp, and that's when you start to move to a telescope. Now, the simplest type of telescope is a lens-based telescope, known as a refractor. Here, I've got a fairly basic refractor. This one's got a lens at the front, which is 90 millimeters in diameter. So that's the light gathering power of this telescope is larger than these binoculars. So the light passes through the lens at the front of the telescope, it's brought to a focus at the end down here, and an eyepiece is used to magnify the image. You can get different types of eyepieces, and they can give you different types of magnification. But this is a great telescope to start picking up things like the craters on the moon, the rings around Saturn, and detail in some of the lovely deep sky objects up there. But the amount of money you have to spend as you start moving up the scale in refractor size starts to become prohibitive. And that's where a second type of basic telescope comes into play, which is known as a reflecting telescope. Instead of using a lens at the front, this one uses a mirror at the back. So the light comes in through the front of the telescope, it hits the mirror at the back, and that mirror focuses the image at the top of the telescope. Now, you can't put your head there because you'd block the light. So there's a small 45-degree mirror in the way which deflects the focusing light off to the side of the tube. And that's where you stick your eyepiece, and that's where you get your view. And the beauty of a reflecting telescope is that because they're less expensive, you can go for larger apertures. That's more light gathering power, and that means you can see fainter objects in the night sky. So something like this is ideal for looking at beautiful galaxies, nebulae, clusters, stuff like that, stuff which has got really faint light, which you really need to grab and throw down the tube of the telescope. To find out more about telescopes and binoculars and the mounts they rest on, have a look at the longer version of my review on the website. Remember, the best type of telescope is the one that gets used.
Our final Christmas treat is a very different way to enjoy the night sky. For many thousands of years, the sky has been our compass, our weather forecast, and our calendar. But most of us have now lost that knowledge. So Chris took a crash course when he met author and natural navigator Tristan Gooley.
So we're here in this field because you're a natural navigator. What's that?
Natural navigation is the wonderful art of working out where we are and how to get to where we want to be, just using nature, just what's around us.
And how does that link to astronomy?
Well, the night sky has always been one of nature's best compasses, and we've got fantastic cultural records from the Pacific Ocean, the Vikings, the Arab navigators, and all of those techniques can still be used today.
The sun's going down over there, we've got sunset, and we've already got the moon up there.
And it's part of our natural navigation toolkit. If we look at the crescent moon there, imagine a line touching the two horns of the moon and then extend that down to your horizon, and you'll be looking roughly south. It's not perfect, but it's giving you the southern horizon.
Well, the first stars are coming out. It's a bit hazy, but we can see them. How do we get ourselves oriented in the landscape?
Well, the best place for us to start is nearly always the plough, and I think we can just make it out just above those trees there, and we use the plough to find the North Star, and that's really our anchor for night navigation.
So how do we do that?
Well, we've got 7 stars in the plough, and we've got 3 that make up the handle and then 4 that make up the pan. And as we look at it here, it's the 2 on the right that form the pointers, and we go from the bottom to the top one and then 5 times that distance in the direction they're pointing, and that takes us up to the North Star.
Tristan's planned a natural navigation challenge. We'll head north into the woods and then try to find our way back using the stars. Tristan's first trick was to pick a feature which he calls a handrail, which will help guide us back to our starting point.
So that's our handrail. A handrail is just a line that you know what direction it runs, and that you'll recognise easily. So it could be a river, it could be a road, lots of things could be a handrail. It's going to be the woods for us tonight. The technique of the handrail is nice and simple. It says you don't need to find an exact point. If you understand where a line is, in this case the line of the woods, and using the North Star and our other stars, we can see that the edge of this woods runs from west to east. And once we've got that handrail, it allows us to kind of be a little, roam a bit. Instead of having to be sort of really worried we know exactly where we are.
Sure.
We're going to be able to go into the woods, and even if we start to feel that we don't know exactly where we are,
we know this edge is east-west.
Exactly.
Good. All right. Well, I'm confident. Let's go and give it a go.
Let's go for it.
Spotting the plough gave us an early confidence boost, and so we headed north from the handrail into the woods. Well, right now I'd like some more clear sky. That would be helpful. I'm a bit worried we're going to get lost now. Without the stars, I've lost my comfort blanket.
Okay, well I can see a path heading down this way, and that looks like a good bet for us to head. If not, back home, then we're going to venture off in a new direction.
All right, let's do that this way then.
Yeah.
Let's go. This new path seemed to take us west, and so I knew home was still roughly south.
So we've come into the woods, but so far it's been pretty easy going. We've been on paths. We had a path that took us north into the woods, and then one that we turned left down, roughly west. We don't know exactly where.
Sure.
We haven't totally lost our bearings, although we can only see the odd star at the moment.
Yeah.
But things are about to get a lot more challenging.
Oh, are they? Good.
Yeah.
I'm glad to hear that.
We are going to head into the woods off the path towards our handrail.
Okay.
And yeah, you ready for that?
Yeah, let's do it.
Let's do
I'm going to make you go first.
Okay, good
And if
plan.
you vanish, I'm running. But otherwise, let's go for it.
Okay.
This is proper off-road confirmed. We've left the path.
Careful, there's some sort of springy bits there.
Yeah, got it. At this point, I knew that we needed to head south to get back. But inside the dense woods, it was harder and harder to work out which way that was. And the clouds weren't helping. Ah, a clearing.
I'm not making out any constellations at the moment, but there's a little technique we can use. If you see the odd star and you've tuned into which way the clouds are moving,
Right.
then unless there's been a massive weather change, that will stay consistent.
Okay, so I can see a star there, and the clouds are going sort of overhead.
Exactly. The clouds are moving from the west to
Right,
the east.
okay.
And so we can use the stars there. Without them, it'd actually be very hard at night to get any feeling for what the clouds are doing.
Right.
So that's giving us...
This is one of the most ridiculous sentences anyone has ever said on an astronomy programme, but I'm glad they're useful to you. Good, okay.
So we've got some idea of our bearings. It doesn't have to be exact. That's the beauty of the handrail. If we know west is out there somewhere...
South must be that way.
Yeah.
Right, okay, so let's head south.
Let's do it, yeah.
There's something up ahead.
Oh, careful, there's a branch here.
Yeah. Got it. Ah, is that the edge?
Oh,
It looks like we're hitting something.
looks like a fence, doesn't it?
It does.
You all right?
Civilization,
Oh,
yeah. I'm
wow,
good.
yeah.
Yeah, yeah, all right.
Okay.
This is the intrepid bit. There we go.
You got it?
Watch yourself, yeah, it's barbed. Very good. And finally, the edge of the woods. And here we are.
We've broken out of our woods.
And this is what you call our handrail, this edge of the wood.
Yeah, and we know it runs west to east, and it's the handrail that's allowed us to explore, to wander, and not worry about getting lost.
It's great to be out here, and whether you're doing what you do or looking at the stars, the more time you spend outside at night, the more you see.
Yeah, I love natural navigation at night. You know, being outdoors at night, a small adventure becomes a really big one.
Well, shall we wander?
Yeah.
Let's do it. My walk reminded me of just how incredible the night sky is, and how time passed just looking up is always time well spent.
That's it for this month. We hope we've inspired you to get outside and look at the wonders of the night sky.
Join us in January when we'll be back with answers to some of the biggest questions of all.
And don't forget to look out for my star guide on the website too.
In the meantime, have a very Merry Christmas and get outside and get looking up.
Good night.
Stay with us, a Tim Peake special, How to Be an Astronaut, next on BBC4.